On this question, once you have found that n of t, I want you to think about what the units represent. So let me go ahead and write down our equation. And you got that from that composition. But notice here that it is a function of t. So it's a function of, and in this case, t represents time. What is it that you're going to get out of this? Well, n is representing the number of bacteria. What that means is that our x value, that's our time, and our y value is going to be the number of bacteria. Having this composition is really useful because now we have a function of time that immediately gives us the number of bacteria. Whereas originally, the number of bacteria was based on the temperature, and the temperature was based on the time. So we basically combine this into one simple equation. So with that in mind, the second question says find the time when the bacteria count reaches 20,890. That's basically saying solve for t, or x, depending on how you think of this, when the function equals 20,890. That's kind of the y value. So when we solve these kinds of equations, we simply want to set the y value, the number of bacteria, we're going to replace that side with the 20,890, and then set it equal to our equation. Now, this particular equation is not the easiest equation to solve. We can, subtract the 20,890 from both sides, but that's still going to give us quite the equation. So I would highly recommend that you go to a graphical software on this, and I don't think that I can switch over to that on this video. So I'll make a second video where I'm working in Desmos, because doing this by hand, it's going to be a nightmare of the quadratic formula because these numbers are so big. But we do need to solve that, and so we would solve that using our quadratic formula since this one will not factor. But I'll show you how to do this graphically in a second video.